All right, on the last video podcast, we looked at the relationship between pH and pOH and the hydrogen ion concentration and the hydroxide ion concentration. We want to continue that on problem number 4, but this is going to be a little bit more complicated. It's not difficult at all as long as we keep pH and pOH kind of separated in our minds. Let's take a look at what we've got here. It says the hydrogen ion concentration of a solution is 2.6 times 10 to the negative 6, and what we want to know is the pH. Now we're going to have to use a calculator this time because this is not 1 times 10 to the minus 6. Had it been 1.0 times 10 to the minus 6, that would have been a simple problem because the pH would have simply been 6 and it would have been all over. But we're going to have to use the calculator at this point, and it's not a problem at all. But here we go. The formula that we're going to use is pH is equal to minus the log of the hydrogen ion concentration. Remember, I could have put hydronium in there if I'd wanted to. So the pH then is equal to minus the log of this value, 2.6 times 10 to the negative 6, just like that. So now I'll just get out the calculator and plug those numbers in. So I'll put in minus log, be careful, not ln, but log, 2.6 second EE negative 6, close the parentheses. That's equal to, I get 5.585, but I'm going to take only 2 significant digits, so I'm going to call that 5.6. So the pH is 5.6. pH is equal to 5.6, and I've got my answer. Now we're going to go a little bit further than the problem requires. I'm going to go ahead and ask for the pOH now. Remember that the pH plus the pOH is equal to 14. So if I know the pH is 5.6, I can say 5.6 plus pOH is equal to 14. pOH is equal to 14 minus 5.6, and that's equal to 14 minus 5.6, 8.4. So the pOH then is equal to 8.4. That's a little bit more than what was asked for, but we need to have a command of these formulas and not just a cursory understanding of what's going on. So be able to move back and forth easily between pH, pOH, hydrogen ion concentration, and hydroxide ion concentration. All right, let's go on to the next set of equations, and that's the exponentiation equations. They're not difficult, but what we do need to understand here is that we've looked at this equation, pH is equal to minus the log of the hydrogen ion concentration, is that from algebra we know that we can exponentiate. I think that's the name that you all use for pushing numbers up to a power. So I'm going to use the power 10. So what I'm going to do first is I'm going to I'm going to multiply both sides by a negative 1. So the first equation is pH is equal to negative the log of the hydrogen ion concentration. So the first thing I'm going to do is I'm going to say negative the pH is equal to the log of the hydrogen ion concentration. I just multiplied both sides by negative 1. And now what I'm going to do is I'm going to exponentiate. What does that mean? It means make 10 the base on both sides of the equation. If you originally had negative pH, make that 10 to the negative pH. If you originally had log of the hydrogen ion concentration, make that 10 to the log of the hydrogen ion concentration. So far we've got 10 to the minus pH is equal to 10 to the log of the hydrogen ion concentration. But we know from algebra that 10 to the log of anything is equal to that thing. So that simplifies the mathematics tremendously. We have 10 to the minus pH then is equal to 10 to the log of the hydrogen ion concentration, which is equal to the hydrogen ion concentration. So I have an easy now relationship between pH and hydrogen ion concentration. I can do the same thing with the pOH. pOH is equal to minus the log of the hydrogen ion concentration. Multiply both sides by negative 1, and I get negative pOH is equal to the log of the OH minus concentration, just like that. So now exponentiate. 10 to the negative pH is equal to 10 to the log of the OH minus concentration. 10 to the log of anything is equal to that thing. So 10 to the log of OH minus concentration is equal to the OH minus concentration. So overall, I've got 10 to the minus POH is equal to 10 to the log of the OH minus concentration, which is equal to the OH minus concentration. All right, let's use our new knowledge on exponentiation to be able to work a couple of problems. All right, here's the first one. It says the pH of a solution is 10. We know it's a basic solution. What is the hydronium ion concentration of this solution? Now we can use a number of different combinations. We'll arrive at the same answer no matter how we do the problem, but let's try this solution. Let's try doing it this way. I know that the pH is equal to the log of the hydrogen ion concentration. The pH is equal to the log of the hydrogen ion concentration. Or I'm sorry, the minus the log of the hydrogen ion concentration. I'm sorry. pH is equal to minus the log of the hydrogen ion concentration. So now I'm going to exponentiate. I say 10 to the minus pH is equal to the hydrogen ion concentration. Okay? 10 to the minus pH is equal to minus the hydrogen ion concentration. Some of you may say, well, you skipped a step. Well, no, I know that 10 to the log of the hydrogen ion concentration is the hydrogen ion concentration. So here's my entire formula. So if I know the pH is 10, I simply say 10 to the minus 10 is equal to the hydrogen ion concentration, which is 1 times 10 to the negative 10. Remember, 1 times anything is just itself. So the hydrogen ion concentration then is just 1 times 10 to the minus 10 if the pH is 10. So pretty straightforward. I didn't even need a calculator. All right, last problem. Let's take a look at this one right here. Problem number 6 says the pOH of a solution is 4. What is the hydrogen ion concentration? What is the hydrogen ion concentration? Now again, you have to be able to move easily between pH, pOH, hydrogen ion concentration, and hydroxide ion concentration. There are a couple of different ways to work this problem. You'll arrive at the same answer no matter how you do it. We want to know the hydrogen ion concentration, but we're given the pOH. Now you may originally say, wait a minute, shouldn't I have been given the pH if I want to know the hydrogen ion concentration? No, you should be able to find the pH if you know the pOH. Remember, pH plus pOH is equal to 14. So if the pOH is 4, the pH then must equal to 10. So I now know the pH is equal to 10, and this problem becomes the same as the one that preceded it. Hydrogen ions and hydronium ions are the same thing. So if I want to know the hydrogen ion concentration, then all I have to do is say pH is equal to minus the log of the hydrogen ion concentration, and therefore we have, if when I exponentiate, I get 10 to the negative 10 is equal to 1 times 10 to the negative 10. It becomes the same problem as the problem that preceded it. Okay, that finishes up the initial calculations for acid-base chemistry. If you didn't quite understand what was going on this video, go ahead and rewind the video. Do additional practice problems. That's the key. The more you practice, the more you're going to understand this process. So I'll see you on the next video podcast. Thank you.